Welcome back. Mr. Sutton bringing you the last of 4 lessons on solving trigonometric equations. In this one, we will tackle equations that have double angle identities built into them. So for our warm-up, we probably shouldn't try to solve equations with double angle identities without first reviewing those identities. Pause the video and see how many you can remember. All right, sine of 2x, that's going to be 2 sine cosine. Tan of 2x, that's going to be 2 tan of x over 1 minus tan squared of x. For cosine of 2x, remember we had 3 for this one. One of them was cosine squared minus sine squared. Another was 1 minus 2 sine squared of x. And the last one is 2 cosine squared of x minus 1. And all of these might be potentially helpful depending on what other things you have going on in your equation. So how do we know, just by looking at an equation like this one, that we need double angle identities? Oh, wait, double angle. Well, that's the tip-off right there. If you have a 2x inside a trig function, that's a very good indication that you need a double angle identity. So use those identities to turn your double angle functions, like sine of 2x, into single angle functions. Now, what is sine of 2x again? Oh yeah, there's that identity that we need. So we can rewrite this as cosine of x times 2 sine of x cosine of x. And now go ahead and pause the video and see if you can tackle the rest of this one on your own. All right, let's see how far you got. So if we multiply these together to simplify it, we've got 2 sine of x cosine squared of x. Now, I believe in the last lesson in this kind of situation, we would have turned this into like 1 minus sine squared of x, and I had only one trig function. But let's just play this out with the cosine squared in there. So we can subtract sine of x from both sides. And that will now allow us to factor out a sine of x. That would leave us with 2 cosine squared of x minus 1. And if we solve that for the trig function, we get 2 branches, well, 3 branches really. We get sine of x equals 0, which we will deal with in a sec. And if we add the 1, divide by 2, and then square root both sides, we get cosine of x equals plus or minus square root of 1/2, which if you simplify that radical, you'll see that's really plus or minus radical 2 over 2. So let's deal with each of these branches individually. Over here, for sine of x equals 0, where does that happen on the unit circle? Well, the y value is 0 at 0 degrees and 180 degrees, so we get 2 answers for that branch. Over here, let's deal with the positive case first. If cosine equals positive root 2 over 2, that means that cosine is going to be 45. That's at least one of your answers. And now we also have a positive cosine in quadrant 4. We have a reference angle of 45. In quadrant 4, that's going to be 360 minus 45, so 315. And then cosine of negative root 2 over 2, that's basically the quadrant 2 version of 45, which is 135. Same reference angle of 45. We also have a negative cosine in quadrant 3, so that would be 180 plus 45, giving us 225 degrees. Here's another problem with a double angle in it. Pause the video and see how far you can get on this one. Now this one's a little trickier. Cosine of 2x, remember there's 3 different identities for that double angle, so you actually have to try to pick the most helpful one based on what else is in your problem. Now we see here this problem also has cosine of x in it, so you probably want to pick the identity that just has cosine in it, not any of the ones with sine. So that would be the identity of 2 cosine squared of x minus 1. So we will substitute 2 cosine squared of x minus 1 on the left side here. And now let's go ahead and solve this one. So let's get everything over to the left side. We can do that by adding the 3 cosine and adding the 2. So that'll give us 2 cosine squared plus 3 cosine plus 1. And now we have to, let's see, this looks like we ought to be able to factor it, right? So how could we factor this? Well, we need a 2 cosine and a cosine in our parentheses. And really, there's only one way to get 1, right? 1 times 1. Can't be negatives because this all comes out positive. So 2 cosine of x plus 1, cosine of x plus 1, those are our 2 different branches. So that means that cosine is going to be negative 1 over 2, or cosine could be negative 1. Let's deal with this second branch first, because this looks a lot easier. Where on the unit circle is the x value going to be -1? Oh, that would be 180 degrees, right? Only one answer there. Not too bad. Keep in mind, they want the equation in radians, or the solutions in radians, so we'll have to convert that in just a bit. But let's go back to this branch now. Now we're asking, where is the x value -1/2? You might remember that that's 120, or you might have to use your calculator. Either way, it is 120. We have a reference angle of 60 if you do 180 minus 120. Now the other place cosine is negative other than quadrant 2 is quadrant 3. So in quadrant 3 we have to do 180 plus 60, giving us 240. And don't forget to go through and turn all those into radians. So 120, that's going to be, let's see, 2 pi over 3. Yep, it's like 2/3 of 180. 180 itself is going to be pi, and then 240, that's going to be 4 pi over 3. Let's do one more. Pause the video and see where you can get on this one. So at the very least, you ought to be able to start by using your double angle identity, right? That again was 2 tan of x over 1 minus tan squared. Now, when I plug this in, I'm also going to subtract this single tan of x over to the other side. And the reason that's a good call is when I have this fraction, it would be much easier to get rid of this fraction if I'm just multiplying it to the other side of the equation. So let's go ahead and do that now. That'll be negative tan of x plus tan cubed of x, if you have tan squared times tan to the first power. We can move everything over to the right side now. So we'll subtract 2 tan of x. That'll give us negative 3 tan of x. And I'm just going to put things in a nicer order. So we have tan cubed minus 3 tan of x equals 0. Well, what do we have to do here? They both have a tan, so let's factor a tan out. That'll be a tan of x parentheses tan squared of x minus 3. So we can say tan of x equals 0. And if we add the 3 and square root both sides, we can get tan of x equals plus or minus square root of 3. Let's deal with this first branch, tan of x equals 0. That one's going to be easier. We're asking where is the slope 0? That's at 0 and 180 degrees. But now let's do this branch here. We'll start with tan of x equals positive root 3. Now root 3, you may kind of remember that that's one of the special values of tangent. I never remember whether it's 30 or 60. I know it's not 45 because tan of 45 is 1. So I'm just going to plug this into my calculator. So I'm plugging in inverse tangent of positive radical 3, which comes out to 60. All right, well that settles it. So we've got 60 degrees. That's the quadrant 1 version of that. Now tangent is also positive, because this was from positive root 3. It's also positive in quadrant 3. This is also a reference angle, so we can just do 180 plus 60 for 240. And now let's do our other branch. That's just going to be the negative version of 60. But that's not between 0 and 360. But it is equivalent to 300 if you do 360 minus 60. So that's the quadrant 4 version that we need. Tangent is also negative in quadrant 2. Reference angle is 60. So for quadrant 2, we're going to do 180 minus 60, which gives us our final answer of 120 degrees. This concludes our final lesson on trigonometric equations. Pat yourself on the head. Confirm that your head didn't explode. You made it. You survived. Good work. Until next time, this is Mr. Sutton signing off.